This is part 2 of the example video for the linear functions unit 4 project. And in this video, I'm going to show how to write an equation in point-slope form and find the slope from a table of a real-world situation. Then we'll brainstorm a realistic domain and range for the function. We'll use that domain and range to set up the graph, and we'll use the slope and y-intercept to graph the function, or the slope and the point to graph the function. Then finally, we'll use that graph or equation to make some predictions. So what's different about this problem is that here I gave you a table instead of giving you numbers in the word problem. So this is about Roberto. Roberto deposits the same amount of money each month into a checking account. Use the table to show your thinking, is what it should say here, and write an and develop an equation. What? I'm not really sure what I was trying to say there. Roberto has a savings account, and we're gonna write an equation for it. We're gonna start off by finding the slope that goes with this table. So there's two ways to find slope, but remember that slope is the change in y, so how much the y changed, divided by the change in x. One way to find slope is to use that change in y over change in x. The other way is to use the slope equation, which is y2 Other way is to use the slope equation, which is y2 minus y1 divided by x2 minus x1. Clean that equation up a little. So that's the slope equation. And a lot of people have told me they prefer this way. Some people like this way better. So I'm going to do the first way better because I actually don't really like using equations and formulas and memorizing stuff. I'd rather just look at the numbers in the table and find a pattern. So first I'm going to look for my change in y. I'm going to look for how much y increased or decreased each time it went up. This was 255, this is 365. So that increased by 110. This is 365, this is 475. So that increased by 110. Then I'm going to come over here and I'm going to look at my change in x. It's not just counting up by 1, so I can't just use this as my rate. I have to come over here and look at how much x changed. From 1 to 2, that went up by 2. From 3 to 5, that also went up by 2. So my change in y is 110, and my change in x is 2. That means that my slope is 110 divided by 2, which equals 55. So I know now that my slope is 55. Here's how I would determine that same thing using the equation. So I'm going to start off identifying my y2 and y1 and my x2 and x1. This is y2, this is y1, just the first and second y. This is x2, this is, sorry, I wrote that backwards. This is x2, this is x1, that's my first and second x. So y2 minus y1 is going to be 365 minus 255 divided by x2 minus x1. So that's 3 minus 1. And again, I end up with 110 divided by 2, which I know is just 55. So that's two different ways to find the slope, and you can use either one, whichever one works for you. So it says, find the slope, m. So m is the slope, so I'm going to write m just to remind myself of that because I'm going to use that in the equation next, is 55. My slope is 55. Then down here, I'm going to substitute the numbers I have already identified here in the table and my slope m into this equation. And this is the format for point slope form. And this is there for you on the project. You don't have to memorize it. You just have to know how to use it and substitute the numbers in. So y minus y1, again, my y1 is right up here. It's 255. I could actually, one advantage of point slope form though, is that I could actually use any of these points. I could use 1 and 255. I could use 3 and 365. I could use 5 and 475, and those would all be correct. So y minus 255 equals m, which was 55, and I know that from my calculation that I did up there. That's my slope, times x minus 1. So that was the 255 is my y1, the m is my slope, and the 1 is my x1. And that's my equation in point slope form. Okay, so on this next page, I'm going to take that equation. Actually, I'll just copy and paste it here. Why not? I'm going to take that equation and I'm going to put it on the graph, and then I'll adjust the graph so that I can see it. Oh, I'm going to skip one more slide over. We'll come back to that one. Okay, so here's my graph. But notice that it's not very useful because it's like really vertical, and it's kind of just like here around -4. And there aren't these numbers on here that'll tell me like how much she saved after, if I want to know how much she saved after 6 months. Here's 6 months and my graph isn't even on here. So I want to be able to see this graph and see the important parts of this graph. And that's where my domain and range come in. So I'm going to come back over here to domain and range. And I'm going to think about this problem. So Roberto deposited, oh, I think I was calling Roberto a she. Well, Roberto can use she, her pronouns if she likes. So we'll keep going with that. So she deposited the same amount of money into a checking account, right? We determined that the amount was 55. She was depositing $55 each month. And so, like, let's just think about let's make this situation realistic. Well, the domain is how many months Roberto might save for. So Roberto can't possibly save for 0 months. Or Roberto could save for 0 months, but Roberto can't save for -1 months. So we know that the number of months, x, and that's the domain. I explained this a little more in the previous video, by the way. The domain is going to be 0 months to, what's the longest somebody would ever save for? Could somebody save for 10 years? Sure. They save for 20 years? Sure. But I feel like Roberto's saving small enough amounts of money that maybe this is a shorter term goal. So I'm going to say 10 years. 10 years, which is 120 months. It's 120 months. Just thinking about what's realistic so I can use that on my graph. Now I'm going to do the same thing for the range. Roberto's savings starts off probably with $0. We don't know for sure exactly what Roberto started off with, but probably at $0, right? If you're saving for something. So 0 to how many dollars would Roberto have after 120 months? That's where my equation comes back in. So I'm going to think, well, okay, here was my equation from the other slide. Y equals 50. This is going to get complicated here. Let's not bother using the equation. Let's just brainstorm still. Domain and range are like a really abstract idea that we use a lot in Algebra 2 and stuff like that. But in the real world, the use of domain and range is setting up that graph. So just thinking about what would be a reasonable amount for Roberto to save after 120 months. If they have 475 after 5 months, let's think about that. Well, that's like $100 a month, $55 a month, right? So 55 times 120, say, is whatever number. 55 times 120. Let me grab a calculator and get that. Didn't rehearse this. I'm just going for it, folks. If you want to fast forward through this part, you can. Okay. Range is 0 to 6,600. And I got that by taking 120 times 55. It might turn out to be a little more than that. It might turn out to be a little less than that, but that at least gives us a starting point. So like a number that we can set our graph to, and then we can zoom in or out, and it'll show us the important parts of the graph. So I'm going to set up my X and Y axis with these same numbers, 0 to 120 and 0 to 6,600. And that'll help this graph make more sense. 0 to 120. Zero to 6,600. Notice how the 0 is right over here against the edge of the screen. That bothers me. So I'm actually going to make this one -10 so that I can actually see the x-axis or the y-axis, and I can see those numbers a little better. And then I'm going to do the same thing with a y here so I can actually see that bottom line. Make that -100. So now I can actually see this bottom line. So by using my domain and range to inform how I set this up, I was thinking about reasonable numbers. Maybe you decided that Roberto would only save for 24 months. You could just zoom in or out on the graph once you've got some kind of brainstorm there, some kind of idea of what's realistic, and then find those points. Okay, so here's my graph, and I can use my graph to make predictions, and I can use it to answer the questions on the next page, or I can use the equation. So that's what we'll do on the next page. How much money did Roberto have at 0 months? All right, so let's go back and use the graph to answer that one. 0 months, that's 0 along the x-axis, because the x-axis here is going to be the months. And the y-axis is going to be the savings. I'm going to go here to this point at 0, and I'm just going to click on that point using Desmos. I'm going to find 0, and I see that the x coordinate when y is 0 is 200. So It's going to be 0, 200. I can tell that by looking at the graph, by thinking about this scale here. If this is 1,000 and this is split up into 5 pieces, then each of these must be counting by 200. 200, 400, 600, 800, 1,000. Okay, so here's my 200. So at 0 months, Roberto had $200. And then how many months will it take for Roberto to save $5,000? Let's go back to the graph and also answer that one from the graph. Here's 5,000. I'm actually going to zoom out a little so I can see that number a bit better. I'll find 5,000, come over here, and I'm looking for what x equals when y is 5,000. Can do this thing where I'm just going to drag it until that y coordinate is exactly 5,000. I can't quite get it. I can get 5,007, like 87.3. Oh, okay. Maybe if I zoom in a little here. About 87 months, because 87.3 of a month is kind of silly. Or maybe we would round up here, because after 87 months, you wouldn't quite have 5,000. But after 88 months, you would. Okay. So about 87 months, 87 or 88 months. So both of those would be acceptable here. Okay. Over here. All right. I am actually not going to do the equation version on this one. If you strongly prefer equations to graphs, that's fine. But remember, the format of this equation looks like this. So you can imagine that solving for x and y in this equation is a little more complicated than on the other one. That's a disadvantage of this form of the equation. It's easy to write the equation and then graph it from these points and then knowing the slope, but it's hard to manipulate and solve. It's harder to manipulate and solve with it. But if you would like me to demonstrate that for you or send you a picture of it, I will. That's it.